In this video, we are going to look at problems 11, 12, and 58 of Chapter 4. Hi, this is Sean Huang from the Physics Department. If you have not, you might want to watch two other videos titled Vectors and Vector Addition and Vector Addition Examples. You can find the links to these videos down below in the description. In problem number 11, we first need to find the vector sum of the two forces. To do this, we'll write each force in its component form and then add them together. The result will be a net force in its component form. Since F equals to ma, the acceleration can be obtained simply by dividing the net force by the mass. The result is the acceleration in its component form, the magnitude of which will be calculated using the Pythagorean theorem, and the direction will be obtained using the arctangent function. We should always try to sketch the vector. From the diagram, you can see that the direction of the acceleration is 27.24 degrees above the positive x-axis. In problem number 12, we have a thrust pointing 55 degrees above the horizontal and a gravitational force pointing straight down. As before, we will write the force vectors in their component forms and add them together to obtain the net force. The acceleration will be obtained by dividing the net force by the mass. This acceleration will be in component form, from which you can calculate the magnitude and the direction just like before. Problem number 58 can be done the same way using the component method, but it will be easier to use the head-to-tail method. Here, we will move F2 horizontally so that the head of F1 meets the tail of F2. You will then draw a straight line from the beginning to the end, and right away you will see a right triangle, from which you can easily determine the magnitude and direction of the net force. Again, since F equals to ma, the magnitude of the acceleration is to take F and divide it by m. And the direction of the acceleration is the same as that of the net force. If you watch the videos, including the two referenced at the beginning of this video, you will see that these problems are all virtually the same. In Physics 2, you will see the same pattern all over again.